My name's Lewis Sykes. I'm part of an artist studio federation based at Talbot Mill in Cornbrook. We're called Cornbrook Creative, and I'm here at Eagle Labs working on a project that's a mini commission for Manchester Science Festival. When we proposed an event as part of the kind of application process for Manchester Science Festival, we also pitched the idea that we'd like to do a commission with colleagues and associates, Noise Orchestra, who are also a Manchester-based sonic artist team. So we were interested in this idea of trying to develop an artist technical toolkit, something that was about developing some kind of technology that would allow us to develop a series of ideas that could grow in the future. And we came up with this concept of sonic pixels. So we're all very familiar with the idea of a screen, and a screen being made up of pixels, and the fact that a screen looks a certain way because certain pixels are certain colours, and that you can paint and draw on a screen. So our concept was, rather than take the traditional mechanism of spatialised audio, which is to use clever effects and panning between multiple speakers to move and position sound in 3D space, we thought, what if you could create a grid of speakers that behaved like they were pixels on a screen, so that you could play any one of a given set of speakers and trigger sound, and therefore move sound around the space. So that's the concept of sonic pixels, really. How do we start to develop kind of sonic concepts, sonic themes, and how do we start realising those? So one idea would be, could we recreate a dawn chorus effect, for instance? By taking all those bird song that happens early in the morning as the birds wake up and recreate that effect of being in the middle of a dawn chorus. So, philosophically, there are a lot of differences between the way that the ocular and the aural are thought about. So we're very familiar with, we live in a very visually dominant world. Vision is our main sense. And actually a lot of philosophy talks about an understanding of our perception based upon an understanding of how we see. But actually, a lot of contemporary neuroscience research using kind of MRI scanners and other types of scanners that can see activity in the brain are actually starting to reveal that our senses all work in very different ways. So this idea that if we learn about vision we can then apply it to all our other senses is starting to be challenged, because audition is actually a totally different perceptual process, both mechanically and neurologically, than sight. Having said that, we talk about visual objects and we talk about tactile, physical objects. We're starting to talk about the notion of sonic objects, but a sonic object isn't like a physical object, because a sonic object, it's temporal primarily. It does exist in space, but it also exists over time. And all those kinds of qualities that we think about, the visual kind of line, outline, movement, dynamic, boundedness, boundaries, they don't necessarily apply when you start thinking about the qualities of a sonic object. But what we're trying to do is to sort of play with this notion that you could take a sound and you could think about it in a visual way. Could we still take audition and treat it in a visual way, but intentionally? So it's this idea of placing speakers in a regular grid, a regular matrix, means that we can then move sound from speaker to speaker. we don't know whether this is actually going to work aesthetically or whether it's going to work in terms of how we experience it. Will it appear to us that the sound is moving around the room? We think it will, but we don't know for sure. It's an experiment. First off, you know, the great thing about Eagle Labs is that it's more than just a kind of an open access introductory space to contemporary fabrication technologies. This is having James as a kind of a technician, but also as a creative practitioner with a lot of skill and a lot of expertise, really moves Eagle Labs into, I think, a different space than something like Mad Lab or something like the Fab Labs, which are great to get an introduction to the technologies. But you know, when you want to do something more challenging, more artistically oriented, there are very few spaces in Manchester that allow for that, and I think Eagle Labs is one of the few of them. So that's great, that's why we're here. We had this concept, I asked his advice, what's the best way do you think we could realise this? And his initial response, well, his immediate initial response was, well, you should be using these, the microbits, which is the BBC plus multiple other sponsors, a little microcomputer made available to every year 7 child in UK schools in 2016. So this is now being introduced as a way to teach code.
They just slot in
schools.
And it now gives you access to all of the pins on the microbit.
Is definitely the starting point. So what James is now helping us to do is to work out a way in which we can communicate with these 25 microbits arranged in the regular grid. That's one thing. The second aspect of it is thinking about the various components that fit into a single unit. The microbit, we're kind of pushing it, really. We're trying to make it do things that it's capable of doing, but there's not a lot of community development or documentation around. So communicating with 25 of them simultaneously hasn't been attempted before, right? So what do we have here? So we have an acrylic tube. This is likely to be the finished sonic pixel unit, a speaker, an acrylic tube, all the electronics fitted inside, some kind of mounting bar at the top so it hangs from a grid. Speakers, I've just looked for and found a car audio 4-inch speaker that seemed reasonably priced and had a fairly wide dynamic range. I found a little 20-watt amplifier. We know that we wanted each sonic pixel to be standalone, i.e. it doesn't need power, so we're thinking about how to power it, and obviously these kind of 18650 batteries that are often used in things like e-cigs and flashlights are really good. This is a little power bank. This costs £1.50 and it allows you to charge the batteries at the same time as use them to drive it. So that's what we're going to do. We're going to run 5 volts into each unit and drive it from a kind of a main power supply, but it will allow us to switch that power supply off and then let each unit run off its battery pack for a while. Various sound modules. We found 2 options really. One is a soundboard made by Adafruit, which has onboard flash RAM. So you're able to load WAV files and just attach it to your computer. It appears like a little flash drive. You just drag the audio files on and then you trigger them. But it's quite expensive. It's about 20 quid, which is a lot of money, considering that we need to try and get each unit down to about £40 production per unit. So I've been testing, and this is what you're hearing now, is another little sound module that uses little micro SD cards and then plays back audio from the micro SD card. And this is £3.50, so there's quite a dramatic price drop. But although I can drive this currently from the Teensy, I have to port the code from the Teensy over to the microbit, and that's another area where James is helping, kind of, providing that kind of expertise in Python, because that's not, I code a lot in C++, Python not so much, and the microbit is Python based, so I'm having to learn as I go. But that's not a bad thing. This isn't far off then what might appear in each unit, so a speaker, a case, a battery pack, an amplifier, a sound triggering module, the microbit itself. The only other additional thing we're likely to include is a fairly bright LED, so that each unit could light up when it's triggered as well. So you'd have this kind of visual reference of sounds playing as well as the owl. Intentionally, they're quite simple devices. They have a store of sound files. They're told to play a particular sound at a particular volume, and they do it. What's interesting is, what can you do with that conceptually? If you've got 25 speakers and you can then tell one of them or all of them to play simultaneously, what kind of sonic effects can you create? What we envisage would be some kind of interface, probably on an iPad. And you'd literally see a grid of 5 by 5 squares, and you'd be able to draw and paint, fill different cells in the matrix in different colours, and those different colours would be representative of different sounds. So actually the user can be sitting there creating sound literally by interacting with a kind of a grid on an iPad, which we think is quite interesting. Artists push technology. They use technology in ways that it was never designed. It's that kind of abuse of technology rather than the use of technology. And I'm really pleased that Eagle Labs are, supportive of that as a way of working. Encouraging artists to come, use these technologies and discover new outputs, new creative possibilities through it. The event that it's going to feature is part of the Manchester Science Festival, which I think runs between October the 19th and the 29th. So it runs for 10 days, all across the city.